Hey everyone, welcome to week 8 of CSM, and today I'll be walking you through question 1 from the worksheet Tricurse. So Tricurse is a standard asymptotic runtime question. We're given function and trying to find a runtime of it. So let's look at the function we have here. The function we have is called mystery, and then we're given an input of size n. And then we have the base case of n equals 0, and where it will turn 0, and elsewise it will turn mystery n divided by 3 times. So basically it'll have recurse by calling itself 3 times when by reducing the factor by n divided by 3. So we've established that this is a recursive problem. So we want to go down the recursion tree and try to figure out what's going on each level. And personally, the way I like to approach recursive asymptotic questions is by drawing out a tree. So we know at the first level, the first call, we have an input of size n, and then we put that in. And then after that, we want to do 3 calls of n divided by 3. So it'll be, we have 3 of these calls to n divided by 3. So this is what's happening at the next level. And then after we do these 3 calls, they each call 3 more times of an input of n divided by 6 or 9, excuse me, and so on. So we know at this top level we have work of 1 being done because there's only 1 call. Next level, there's the work is equivalent to 3 because there are 3 calls to the function, and the next is 9, and then so on. And if we look at it, we can generalize this pattern as being 3 to the k work being done at each level, where k equals the level. So, for example, the next level would be 3 to the 3 work being done there. So now we know how much work is being done at each level, but we don't know how many levels are there. So let's look at this tree. So we know it's going to terminate when n is equal to 0. And right now at every call, the value of n reduces by 2/3, or it's become 1/3 its original value. So since it's being reduced by some constant factor, or it's being divided by a constant factor, that means the height of tree is going to be log n. So what we know about this recursive tree is we're going to have 3 to 0 work being done first, and then 3 to 1, 3 to 2, so on into the last level, which would be the 3 log n level. And so this is the sum we want to do. We're adding up all the work that's been done throughout the whole call. And then we want to actually figure out what it equates to. So we know 3 to 0 equals 1, which is 1 equals 3, and then we have 9, so on. And then eventually we'll get to n because that's the original value of the input we want. So we want to sum up this, figure out the sum. And the thing is, one thing we should know about the sum is that it's a sum of a value to an exponential factor, or we're given it's some number to an exponential factor that's increasing every single time, 3 to 0, 3 to 1, 3 to 2, etc. So what we learned in class is that these types of summations will always generalize to a theta n runtime. So because we get this pattern of of exponents, we know that it will have to generalize to a theta n runtime. So yeah, so the runtime of this function on the input of n would be theta n. Yeah, hopefully that helps you approach a recursive asymptotic problem better. And yeah, see you guys next time.